So this is the first video for Unit 5. Unit 5 is all about graphs of the trig functions. We're going to start off talking about sine and cosine functions. We're actually going to take 2 days to do that. Then we'll move on to tangent and cotangent and cosecant and secant. This is the first video for Unit 5. It might be the last video for Unit 5, depending on what you guys want. If you want to keep the videos, you got to let me know. If you want to switch to a lecture, you got to let me know. We'll talk about it in class next time to decide which we're going to do. So this video, since it's really kind of drawing heavy, is going to be pretty much focused. There's just going to be a PowerPoint that I'm putting up after this. So go ahead and enjoy that, and we'll see you in class.
Okay, so the first thing we're going to do is we're going to graph this new function, f of x equals sine x. So we're going to take off the unit circle and we're going to move into graphing things on the same old coordinate plane you were used to seeing before. If you look on the left of the picture here, I just copied the unit circle chart for sine of x for all the values we know. And all we're going to do is for x and f of x, plot them on the xy axis. So here's my xy axis. You'll notice I used weird values for x. I used pi halves, pi over 3, and 2 pi. That way, when I graph the coordinates, it'll be on lines. And I have I have 1/2 and 1, because the biggest value I have on the chart on the left for the f of x, for the y value, is 1. So I'm just going to plot all those on there. So first is 0, 0. Then is pi over 6 and 1/2, which is about right there. Pi over 4 and root 2 over 2. Root 2 over 2 is about 0.7. Okay, then I have pi over 3 and root 3 over 2, which is about 0.8. Well, it's 0.86, so it's 0.9. So it's up there. And then I have pi over 2, 1. Okay, then 2 pi over 3 and root 3 over 2. 3 pi over 4 and root 2 over 2. 5 pi over 6 and 1/2. And pi is 0. Then I have 7 pi over 6 is negative 1/2. 5 pi over 4 is root 2 over 2, negative root 2 over 2. 4 pi over 3 is negative root 3 over 2. And 3 pi over 2 is negative 1. Then I have 5 pi over 3 is negative root 3 over 2. 7 pi over 4 is negative root 2 over 2. And 11 pi over 6 is negative 1/2. And then 2 pi is 0. So I have a whole lot of points there, and hopefully you can see the shape that's going to come out of that. And I'll just trace it here. And that's the shape we have. That shape is called a sine wave. It's one of the most important shapes in math. So let's just look at that for a second. Okay, done looking at that. Now let's do cosine. Okay, cosine I'm not going to go as crazy. You notice I changed the values for the chart so they match the cosine values from the unit circle rather than the sine values from the unit circle. But I have the same chart. Only instead of graphing all those points, I'm just going to graph the most important ones. And that's 0, pi halves, pi, 3 pi over 2, and 2 pi, because those are the ones that are on the x and y axis when I drew the unit circle. So, 0, 1, pi halves 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. So you can see the shape here goes just like that. And that's the graph of cosine from 0 to 2 pi. But what happens outside of 2 pi? Let's talk about that. So up top on the left, I have the unit circle, and down on the bottom is where I'm going to be graphing the function. So as we go around the unit circle once, sine, and the graphing sine in this case, sine does that. We just saw that on the last page. That's what sine looks like. If I go through the unit circle twice, so I'd be bigger than 2 pi now, I would get the same shape, because really I'm talking about the same values, right? As I go around the circle, the spot was in the same place. And as I keep going around the circle, this wave keeps repeating itself, and it repeats itself every 2 pi. So we call that the period. The period of a function is the x-axis distance where the function is going to repeat itself. So in this case, I hope you can see that since the unit circle repeats itself every 2 pi, right, it goes around the circle 2 pi radians, so every 2 pi it repeats itself. The period of sine x and of cosine x for both of them is going to be 2 pi. You can see cosine on the bottom of this page, and hopefully you can just imagine what cosine would look like. So the domain and range of these functions, well, there's the sine on the left and cosine on the right. The domain and range for sine and cosine. So we'll talk about the domain first. Well, no matter what value I have going forward or backwards, those waves are going to keep going up and down to infinity. So the domain for each of them is negative infinity to infinity. The range, though, doesn't. You can see these waves go up and down, and they go from 1 to -1. They never go outside of below -1. They never go above +1. So I can say that the range, remember the possible y values is the range. The possible x values is domain, and the possible y values is range. The possible y values for these functions are any number between -1 and 1. And that's true for both of them. Okay, so the domain is -infinity to infinity. The range is -1 to 1. Okay, so now let's look at that graph again. There's a new wrinkle we have to add, and that's called amplitude. The amplitude of a periodic function, and both sine and cosine are periodic because they have a period. We'll call that A. The amplitude of a periodic function, amplitude is A, is the height that the graph goes either above or below the x-axis. So if you see these two arrows there, those both represent the amplitude of this function. Now for the functions we've dealt with so far, sine x and cosine x, the amplitude of the function is 1. It goes up to 1, it goes down to -1. It only gets 1 unit away. So as I said again, the amplitude for f of x equals sine x and f of x equals cosine x are both 1. Now we're going to change it up a little bit. Now we have f of x equals a sine x and f of x equals a cosine x. You'll see what's different now is I have an a out in front of the sine and an a out in front of the cosine. They weren't there before. That a represents the amplitude. So each of these functions is the same shape as the previous function. So a sine x is the same basic shape as sine x, and a cosine x is the same basic shape as cosine x. But instead of going back and forth between -1 and 1, they go between -a and a. And that should make sense because before, if I put a 1 out in front of sine x, if it was 1 sine x, that would be the same thing as if I said sine x, because 1 times sine x is sine x, and 1 times cosine x is cosine x. So if a was a 1, then I would get the exact same graphs I had before. So right now I'm going to take those examples and I'm going to show you what a graph would look like when all we're changing is the amplitude. So we're going to graph the function f of x equals 2 sine x. And my graph is nice and big. I'm going to do 2 periods in the positive axis and 2 periods in the negative axis. So I have to go from -4 pi to +4 pi. And on the y-axis, since it's 2 sine, I know the amplitude's 2, I have to go at least to the number 2. The first thing I'm going to do when I draw this is to graph out what I had before, what my sine looked like before. So I started at 0, and as I moved right, I went up to 1, down to -1, up to 1, down to -1, and back to 0. So every 2 pi, that function repeats itself, and it does the same thing if I went left. So you see in the negative values, it goes down to -1, up to 1, down to -1, up to 1, back to 0. So that's what sine x looks like. That's why it's dotted, because that's not 2 sine x. That's just sine x. So now I'm going to go ahead and graph f of x equals 2 sine x, which means the only thing that changes, we still have the zeros in all the same place. We still have the maximum and the minimum. So it goes up to a certain point and down to a certain point. Only that certain point, instead of being up to 1 and down to -1, is now up to 2, down to -2. Up to 2, down to -2. Same thing on the other side. Down to -2, up to 2, down to -2, up to 2, and there we have our graph. And we can take away the dotted lines so we can just have the graph of f of x equals 2 sine x. And that's all we have for today.